Okay, so we're going to talk about solving absolute value equations today. So we're still in Unit 2, absolute value equations, and that's going to be page 38, possibly 39 in your notes. Just give you a second to write that down. Okay, so you should have that TOC down, so let's go ahead and go out to page 38. Sorry, make that page 39. 38. So this will be solving absolute value equations. So first off, we should know what absolute value is. So absolute value the absolute value of a number is the distance when we say distance, we mean number of units. And a distance cannot be negative. You can't run negative 2 miles. A number is from 0 on the number line. For example, the absolute value of 4 is 4, and the absolute value of negative 4 is 4, because they are both, since both numbers are only 4 units away from 0 on the number line. And that's what we're going to find when we're solving an absolute value equation, is that we have to look at it that every number, right, there's both a positive and a negative number that is equal distance from 0 on the number line. So what is an absolute value equation? Basically is an equation that contains absolute value. Both the positive and negative cases must be considered when solving. So if this is our number line, here, we just have a number line, and we say, 0 is right here. Well, there's a positive 2 that's 2 units away from 0, and there's a negative 2 that is 2 units away from 0. So this distance and this distance represent the same length, the same distance. So with that in mind, that's why we have to both consider the positive and the negative cases when we're solving an absolute value. So let's look at the steps for that. So step number 1 is going to be isolate. Okay, so we want to isolate the absolute value expression on one side of the equal sign. So kind of like when we say when we're solving an equation, we want to know the value of x. Here we want the absolute value expression by itself on one side equal to a fixed number, or things that are in not absolute value on the other side. Step number 2 is 2 sets, or cases. Write 2 set cases of the equation. Set number 1, positive. Step number 2, negative. So again, we got to take into account both cases. Step number 3, solve. So solve both sets using the 5 steps for solving equations. And hopefully at this point we know the 5 steps: distribute, combine, rewind, solve, and check. Special case: no solution if the absolute value expression is equal to a negative. And we'll look at and see what that looks like. Oh wow, give you guys a minute here to catch up, since I didn't realize you guys couldn't see. That's the toughest part about not having kids in front of you. So I'll give you a minute here to make sure you have everything written down. Okay, so let's move on. Step 4, check. Check solutions. To ensure they create true statements. And step number 5, solution set. Because we have 2 cases to consider, both the positive case and the negative case, we often wind up with 2 specific answers. So it's not an infinite set, but it's a set of 2. So we have to write the solution set. Write solution set in brackets. And we don't want to use parentheses because otherwise it looks like a coordinate point. Okay, so what does this look like? Let's do an example problem. So say we're given absolute value of x plus 3 equals 7. Well, isolate. It's asking us, is our absolute value by itself on one side? And it is. So this is a step we don't have to perform. Write 2 statements. So we're going to take x plus 3 equals 7. You'll notice that it's no longer inside of the absolute value. So this is me writing the positive case. So the answer is 7. And x plus 3 equals negative 7. Now I want to solve them. X plus 3 equals 7. I'm going to subtract 3 from both sides and get x equal to 4. And x plus 3 equals negative 7, negative 3, x equals negative 10. So then to check my work, absolute value of 4, so me putting it back in, 4 plus 3 equals 7. 4 plus 3, because absolute value bars act like a grouping symbol, 4 plus 3 is 7, and the absolute value of 7 is 7. Second one, absolute value negative 10 plus 3 equals 7. Well, inside negative 10 plus 3 equals positive 7, and that will equal 7. So my solution set is negative 10 and 4. You can see I write them in increasing order. Let's see if we can fit one more in where we have to isolate. So what if we were asked to do 2 times the absolute value of x minus 8 equals 28? Well, my absolute value isn't by itself over here. It has a 2. So I'm going to have to undo that 2. It's being multiplied by the absolute value. So I'm going to multiply both sides by 1/2 to get the absolute value of x minus 8 equal to 14. So my set is going to be x minus 8 equals positive 14, and x minus 8 equals negative 14. So x minus 8 equals 14. X minus 8 equals negative 14. So add 8, x equals 22. Add 8, x equals 6. So 2, because I want to go back to the original, 2 times 22 minus 8 equals 28. 22 minus 8 is 14. 2 times positive 14 will give me 28. And over here, I'd have 2 times, this would be a negative 6. negative 6 minus 8. Well, 2 times the absolute value of negative 14 will still equal 28. So negative 6, 22 are my solutions. Okay. And that's how you solve absolute value equations. We're not really adding much difference here other than we're writing the two cases and we're changing one of our answers. We're flipping the sign. When we said about that special case, okay, special case would look like this. So a special case would look like x minus 4, absolute value of x minus 4 equals negative 2. Can't be equal to a negative 2. The key here is that you need to check after you isolate. Okay? So for example, if I had negative 3 times the absolute value of x plus 4 equals negative 2. Well, when I isolate this absolute value, I get rid of that 3, I'm going to wind up with x plus 4, absolute value of x plus 4 equals positive 6. So I would be okay there. It's not equal to a negative. So you check for the special case after you've isolated. And that's how you solve absolute value equations.